do have examples ready to go for this week.
No, I just wanted to see the examples. I've done like the assignment and the discussion, but I
Oh,
wanted to
great.
just get on and just go through and just, it's always a help when I get on and just go through the examples and, hear you go over the stuff. It's always a help. So,
Okay,
yep.
no, great. That's awesome that you did that. Okay, and if you want to just email me the assignment, I can check through it and correct things or clarify things before you turn it in.
Oh, okay. Oh, yes, I will do that. Yes,
Okay,
that would
yeah,
be
no
great.
problem. I can do that. And you can also go back and fix any of your other assignments if you want for
Oh, okay.
it, if you have
Oh,
time,
okay.
go ahead and do that. And next week is the last week of new material, so um, that'll be, and it's going to be easier, so that'll be a good thing too.
Okay.
The
And
last week
I
is
will say, it's, yeah, but it's always, no matter what the class is, week 5 is always that week. And I just did not devote, as you can see, I missed the session last week, and I was just like, oh, I had so much going on. I was like, oh,
no, and it was Easter too, so I understand.
yeah, yeah.
But go ahead and if you want, go ahead and redo that stuff and just resubmit it.
Okay. Oh, okay. I will definitely do that. That's great.
Okay, so this week we're talking about hypothesis testing, and
Mhm.
what I want to say is that like last week we used the example from the ABC Enterprise. We used the example to tell us about populations, and we've been doing that actually this whole semester. So I
Mhm.
know a lot of people don't. Think that one example can tell us, give us any information, but it does. And this week is pretty much the accumulation of all that we've talked about or studied. And we're going to use one example to test our claim and see if the claim is good enough. I mean, we can't actually prove that it's true. In order to prove that something is true, you have to be 100% certain. And there's just no way to say that you're 100% certain when you're like performing an experiment or doing a survey. You're not going to get, 100% certainty. So we are going to be able to say that it points us in that direction, though. So
Mhm.
example is enough to give us a lot of information about what we think might happen in a population. So I really want to make that clear that yes, you can use one little example to decide if maybe, if the example is good enough or if it's large enough, but we can use that example to make a lot of decisions. So this is going to be like the big week, the overview pretty much of everything we've talked about. So we have three kinds of tests, actually, just like we had three kinds of confidence intervals that we studied. There are a lot more, but we did the Z um, confidence interval using the Z for a normal population. Um, we use Z if we know the population standard deviation, and I'll write this down in a minute. And I have recorded so you can go back. And we also, for confidence interval, we use T. And T was when we did not know the population standard deviation, which is true in most cases, and we knew the sample standard deviation. So we didn't know the overall population, but we did know the sample standard deviation, and that's when you use T. And then we use the
Mhm.
proportion when we had a proportion for confidence interval. And again, we use Z for that. And so those are the three types, but we're only going to do two tonight, and you're only going to have homework on 2 types, so that kind of narrows it down a little bit. Okay, so why do we do hypothesis tests? We do hypothesis tests to see or to show that there's an observable phenomenon, and it points us in the direction of our claim. So we can do a test to say, yes, the claim is probably true, or there is a relationship, or no, it's not. And so we'll go through the steps today to show you how to do that. Okay, so there's the Z. There's going to be a Z test if it's normal. And this is if the population standard deviation is known. And that will be in the problem. A T test if the population standard deviation is not known. But we know the sample standard deviation. And then the proportion, which you did for confidence intervals. And it's just like number 1, you do it the same way, but we're not going to do that in this week, but we use Z for that also. So it's pretty much the same as confidence intervals. So we're just going to do 1 and 2. But I'm going to do 3 examples. So the first example I'm going to do is let's see, and I'm going to use the P method. There is in the book about critical values, but where you use the table, but you don't always have the table. And I think that the P method makes more sense, and I'll explain it as we go. Okay, so I'm going to write the problem down. So our first problem is that a researcher wishes to test the claim that the average cost of tuition, and I'll say and fees, at a 4-year public college is greater than $5,700. Okay, so she selects a sample of 36 4-year public colleges, and the mean is 5950. The population standard deviation is $659. Alpha is going to be 5%, and that's usually the case. That's our level of significance. I'll talk about that in a minute. Is there evidence to support their claim? Okay, so there's our problem. That's all the information we need. As you're reading through the problem, you should write down the numbers. But the first thing actually you should do is decide the claim. Okay, so find the claim in this problem. And usually it'll have the word claim in it. So in this problem, it says, a researcher wishes to test the claim. So here's the claim right here, that the average, and it'll always involve a mean. Okay, so the mean cost is greater than $5,700. Okay, so that's our claim. And you always have to decide that first, and it should be somewhere in the problem. And that's really important that you don't get the claim mixed up with the sample. So the important thing, again, is don't get the claim mixed up with the sample. So the claim here is that the mean cost is greater than $5,700. So let's write that out. Okay, so it's also important when you're doing the homework to use the correct symbols. Okay, so we're going to use the correct symbols. So first thing is decide claim, and we did. The claim is the mean is greater than $5,700. So we'll change that and put that into math symbols. Once you decide the claim, then you decide your hypothesis. So the second step, and these can be all numbered differently. You decide your hypothesis. So the second step, and these can be all numbered differently. But once you decide the claim, you do your hypothesis. So you have the null hypothesis and you have the alternative hypothesis. Now, how do you decide? It's really easy. It doesn't have to do with the claim. It has to do with the equal sign.
Mm-hmm.
Okay, so the null always has the equal sign. So it could be equal, it could be greater than or equal to, or less than or equal to. Now, when you get in different books, it's different, but it's always in every single book. It's always the null has the equal sign. So let's see. The notation that you're going to use is you use H for hypothesis, a little zero for null. Null means zero. And then you put colon mark. And then you put mean, use mu for mean. And since the claim is greater than 5,700, that's going to go to the alternative. That doesn't have the equal sign. So that automatically means that the alternative is going to be that the mean is greater than 5,700. And then once you decide that, this always has the equals. That has to be the opposite. So that's going to be less than $5,700 or equal to. Okay, so does that make sense? The claim isn't always the null hypothesis. The claim, it just depends. If it has the equal sign, the one with the equal sign goes with the null always.
Oh, okay. Okay. I'm tracking. The equal always goes with the
null.
The null. Okay.
So let me write that out again, because that's really important. You have to get that right or the whole thing's wrong. So the claim is the mean's greater than 57. So immediately, since that one does not have the equal sign, this immediately goes with the alternative. Not always, but in this case, yes. And then this is going to be opposite, totally opposite. So this one's going to be the mean less than or equal to 5,700. And you can put the dollar sign in or not, doesn't matter. So decide where the claim is based on the equal sign. The null always has the equal sign. If the claim doesn't have the equal sign, then it goes to the alternative. Okay, so does that make sense?
So can you say that again?
Okay, so our claim, you understand that the claim is the mean is greater than 5,700?
Yes, I understand
Since,
that part.
okay, since that does not have an equal sign, that does
Hmm.
not go with the null. It has to go
Okay.
with the alternative.
Okay.
If
Okay.
if the claim was the mean is greater than okay, sorry. If the claim was the mean's at least 5,700, that would be greater than or equal to. At least means greater than or equal to, and then that would go with the null.
Then the equal would go with the null at that
Yes.
time. Okay.
Yeah. But I mean, don't change the claim. If the claim doesn't have the equal sign in it, then it goes with the alternative.
Okay.
So the alternative could be, let's see, the alternative could be not equal to, less than, or greater than.
Gotcha. Because it's always opposite of the null, correct? It's the opposite.
Always
Okay.
opposite. Okay, so now we have to determine what test it is. So let's look at our example, step 3. Our example was 36 colleges, and the mean of that example was 5950. And the population standard deviation was 659. So let me write down everything else. So we're going to use the sample to test the claim. So this sample is going to give us information about our population. We're going to see if the mean is actually greater than 5,700. And again, the numbers really don't mean anything here. So I just want to go through the steps for any problem. So here I just wrote everything down. Now, since we know the population standard deviation, that tells us what test to use. That is the z-test. If we don't know that, if the standard deviation comes from the sample, then that's the t-test. So the z-test, because we know the population standard deviation. That's how we decide. So I'm going to draw a picture of this. And you get a go ahead. Go ahead.
Oh, I didn't have anything. I was switching. I'm at my house now. I'm sorry.
Oh, okay. No, sorry. Just jump in anytime. Okay, so my
Okay.
picture is going to look like this. It's going to have a normal curve, and the claim is going to go in the middle. The claim mean is in the middle. So the 5,700, your claim always goes in the middle. And then we're testing the sample. The sample is what we're testing, and that was 5,950. Is what we're testing, and that was 5,950. And what we're testing is the probability that any sample is going to be over here. That's called P for probability. So we're testing if we're going to assume the null is true. P is the probability that we get a sample or more extreme sample, that we get example or more extreme example over in that region. Now, how do I know to color the right side? I'm going to switch my screen. I'm going to try something new. I found a new whiteboard, so I have more room. So hold on a second, and I'm going to try to switch this over to a bigger whiteboard. Okay, can you see that?
Yes.
Okay, great. All right, so I have a bigger whiteboard. Okay, so so it's the probability that if the null is true, if we assume the null is true, that we get a sample over there. Now, how do we know it's over there? Okay, well, it goes back to our hypothesis. The null always has the equal sign. The alternative decides the tail. So the tail, like I colored on the right side, if it's like that, it's the right tail. If it's greater than. If it's less than, it's the left tail. And if it's not equal to, then it's two-tailed. It's both sides. So our picture looked like this. The claim was in the middle, 5,700. Our example gave us 5,950. Now we want to find the probability that we would get that example if the claim was true and it's right-tailed, because our alternative hypothesis was the mean was greater than 5,700. So greater than means right-tailed. So the alternative tells us the tail.
Okay.
And we want to find this probability. All right, so we're going to use the normal calculator. And the mean that we're going to plug in is, you can use z-scores if you want to, but for the z, we're just going to use the regular mean. We're not going to do the standard normal curve. We're not going to find the z-score, but we could. I guess I should do it both ways. We'll do it both ways. Okay, for the standard deviation, you're going to do the standard deviation divided by the square root of n because of the central limit theorem. So our standard deviation was 659, and our number in our sample was 36. So when we use our calculator, let's see. This is 109.833, and we're going to plug it in, and we're going to get our area, but our area under the curve, remember, is the same as probability. So we want to know the probability that our example would end up over there. Now, what will that tell us? Well, if our probability is low, the null goes. I use a little rhyme. It's easier to remember. So the null gets thrown out. So if P is less than our significance level, which is alpha, if it's less than 5%, then we reject the null. And it points us to the alternative. It doesn't tell us the alternative is true because we can never prove that it's true, but it does tell us that there's sufficient evidence that points to the alternative when we throw out the null. If P is high, the null flies, but that doesn't make sense to me, so I just say the null stays. So P bigger than 5%, then we do not reject the null. And we can't say the null is true, but we can't say that there's enough evidence that points towards the null. So what we're doing is using that sample to test the null or our claim either way. So we're going to go to the calculator. So let me go back and find it. Okay, so let me share my screen. Okay, so we're going to go to the same calculator we've been using, and I have the link set up for you. So we type in 5,700 for the mean. That's the claim mean. 109.833. That was the population standard deviation divided by the square root of n. And then we want it above because it's to the right, 5950. So we want the probability that, and you look at the picture, that tells us it's right-tailed, which it's correct. So we want that shaded region, which is the probability, and we get 0.0114. So it's really, really low that we find a sample over there. So since we did find a sample over there, but the probability was low, then we have to throw out the null. Okay, so we use the claim mean, we use the standard deviation divided by the square root of n, and it's above because it's right-tailed, 5950, and the probability that would happen is really low. It's 0.0114. So let's go back. I guess I can just keep sharing the. Okay, so probability 0.0114. It's less than 0.05. P low, null goes. So this is step 4 to do the test. Step 5, and again, you can number them differently maybe, but I think I'm doing it the same as in the text. Step 5, decide whether to reject or keep the null. So in this case, we reject the null. And then step 6 is conclusion. So our conclusion, since we threw out the null, and remember the null was that the mean was greater than 5,700, it would say that there's sufficient evidence that the mean is not greater than $5,700. Oh, sorry, it is greater. The null was, I'm sorry, that's bad. The null was that the mean was less than 5,700. I just look at it in my notes. So the mean is greater than 5,700. That was the alternative. Let me fix that. That was the null. So when we reject it, we go with the alternative. But we can't say 100% that the mean's greater than 5,700, but the evidence points to it. Okay, so that was a lot for one problem, but I think once you do a problem and you'll see the steps, it gets a lot easier.
Okay.
So the other way to do that would be just to use the z-score, because we have to do it this way for t, so I'm just going to go through it. The z-score is the sample mean minus the claim mean over the standard deviation divided by square root of n. So if you get the z-score for this, and then do the normal calculator with the mean 0, standard deviation 1, great, and then above 2.2762, that's using the standard normal curve when you convert it to the z-score. So let's see what happens there. Go to the calculators, 0, 1, 2.2762. Oh man, okay. Press the wrong. Okay, and you get the same area point, you get the same probability 0.0114. So that's using the z-score with the z-score formula. But again, you could have just plugged in 5,700 for the mean. For the claim, the standard deviation is divided by square root of n for the ST, and above the 5,950, and you would get the same answer.
Okay.
So you can do it either way. Now we're going to have to do that for the t. So the next example, I'm going to look at is this one. So look that over while I'm writing this problem, and then we'll talk about it. So if you have any questions before we do this problem. infections. So is there evidence to reject the claim? Again, we're going to use the sample to tell us about the claim of the population. So medical investigation claims that the average number of infections per week is 16.3. A random sample of 10 weeks had a mean of 17.7 infections. The sample standard deviation is 1.8. Is there evidence to reject the claim? So the first thing you have to do is find the claim. Well, it's the first sentence usually.
Mm-hmm.
So
It's saying that it's equal to the 16.3.
Very good. Yes, is means equals. So the average mu equals 16.3. Okay, now you have to decide what is the null and make sure you write this out properly. You do, and they use H alpha, but you can use HA, and then with a little colon mark, and then with the mean, and what goes where.
Okay. So the mean would be let's see, the average of it. So equals is the first one, and then the next one will be not equal to the 16.3.
Yeah. So how did you decide that? Well, you said the equals always goes with the null.
With the null, yes.
Yes.
Then the other one would be the opposite, which would be not equal.
Right.
Okay.
Yes. That's how we're going to do it. I mean, there's other cases you could put when you get more advanced into researching, but we're always going to do the opposite.
Okay.
It's not going to make any difference.
Okay.
So this also tells us what kind of, the alternative tells us the tail. So this is going to be two-tailed because we have equals and not equals.
Mm-hmm.
So alternative hypothesis tells us the tail. What kind of tail we have. Then I'm going to draw a picture. And I always draw a normal curve. T isn't always normal, but it's, you know, pretty close. So the claim always goes in the middle. And our example mean is 17.7. So we have this side and we have this side. Now it's kind of easy to find that other number. We don't need to, but to find that other number, you would just subtract subtract these two. Let me go back.
Okay.
So let me just do it off the side. 17.7 minus 16.3. Let's see how far apart those are. Just 1.4. So we're going to subtract 1.4 from the middle on the other side because they're symmetric. And we'll get 14.9 here. Again, you don't have to do that.
Okay.
Okay, then we decide what type of test this is. And if you go back, I like this whiteboard. If you go back, it says a random sample of 10 weeks had 17.7 infections. The sample standard deviation is 1.8. We only know the sample standard deviation. So this is the same thing you have to do for the confidence intervals. Since we only know the sample standard deviation, we have to use T. Because we don't know the population standard deviation not known. That's the only difference. That's what tells you to use Z or T.
Okay.
Which standard deviation is known. Now, some books, you have to worry about the size, but if you read our text, this is the only thing that we have to worry about. We don't care about the sample size. It's whether we know which standard deviation we know. If we know the population, it's Z. If we don't, it's T. Okay, so since it's T, we have to use the T formula here. We don't have a calculator like we did for the Z curve. Okay, so it's a little bit more complicated, but it's just like the Z formula. So our T formula is the sample mean, which is 17.7, minus the claim mean, which is 16.3, and it's always in that order. So it could be negative, so don't worry if it's not. It doesn't always have to be positive, it could be negative. And then you divide it by the standard deviation square root of n. So standard deviation is 1.8 divided by the square root of 10. Our example had 10 weeks in it. So if we go back and read it, 10 weeks had a mean of 17.7. So when we work that out, we get 2.4595. And then we go to the T calculator. Okay, so I'm going to go to the T calculator. And it's number 12. And that gives us our probability. So if you're using this calculator, it gives you the two-tailed answer. Some other calculators, you just have to be careful which one you have. Now, our problem is two-tailed. If it was only one-tailed, we would just divide the answer by 2. And I'll show you that later in the next example. Okay, so don't worry about that yet. So we have a two-tailed case. So it's 2.4595 is what we type in. Degrees of freedom is n minus 1. So degrees of freedom is, and I explained that. I made a real short video explaining the degrees of freedom, so I'll send that out as an announcement. But it's n minus 1, so we're just going to put 9 here, 10 minus 1, and we calculate it, and we get 0.0362. So the probability that we get a sample if the null is true over there, is 0.0362, which is small. So we put in T in our calculator, degrees of freedom, and the probability is 0.0362, and that's 2 tail. And I'll just write this out now. If we need 1 tail, we divide by 2, but we don't here. So then we decide to keep the null or not, but that's less than alpha. It's our significance level, 5%. So P low, null goes. So we reject the null again. So our conclusion there is sufficient evidence that the mean is not 16.30. So it points to the alternative. And I can just briefly talk about degrees of freedom, I guess. The example is, when you find, suppose you have 10 people in a class and you want to find the average. So you're going to add up 10 tests and divide it by 10. You're going to add up the scores of 10 tests and divide it by 10. Okay, so if you had 9 people, 9 numbers change, so they're floating around there, like they can be free. You have 9 free numbers. One of them has to be fixed in order for you to get the same mean. Okay, so like if one score goes up and another score goes down and you want the same mean, then one of those numbers has to be determined by the change of the other 9. I don't know if that makes any sense, but I did do a short video with an example. I wrote out numbers to show you. So that kind of explains the degrees of freedom. 9 numbers can be free. One of them has to be fixed.
Okay.
Okay, so this is getting a little easier as we go. I do have one more, and then if you have any questions, we can go over them. But I think you're getting the swing of things.
I am.
Good. So let's talk about this one. And you'll see they all pretty much read the same. Okay, so this example, what they did was actually give listed the 8 school districts. So I just used Excel to find the mean and the standard deviation of that sample. So we only know the sample standard deviation.
Mm-hmm.
So first thing, claim. So educator claims that the average, so the mean of a substitute teacher's salary is less than $60 per day. So the mean is less than $60.
Mm-hmm.
Then we're going to decide the hypothesis.
Mm-hmm.
Make sure you use the right symbols. So you have to decide which one. Go ahead.
Let's see. The hypothesis would be less than 60, and then less than are not equal to 60. No. So on this one, do we have to have the not equal, or could we just say not less than, because it has to be the opposite? Would it have to be greater than or not equal to?
Okay, decide where does this one go first?
So let's see, is the less than 60 would go in the null. No, the null, yeah, the null always has equal, right?
Right.
Okay. So in the alternative.
Mm-hmm. So what is, if the null is always opposite, what's that one going to be?
So it's going to be greater than or not equal to?
Well, greater than or equal to, because it always has
Or
to
equal to, yeah.
Yeah.
Yeah, greater than or equal to, not equal to, greater than or equal to the 60. Yeah. Okay.
Right. So if the null is greater than or equal to, then the alternative will always be less than. If
Then less
it's
than.
less than or equal to, then the alternative will be greater than. And if it's equal to, then the alternative will be not equal to.
Equal to. Gotcha.
Well, there's only three things that can happen. There's only three things that can happen.
Okay.
So that's the first case. The alternate, you were right with the alternative because it didn't have the equal sign. If it was less than, then the null would be greater than or equal to.
Okay.
All right. So once we got that, the null always has the equal sign, and use the same number, 60. That's the claim. Okay. So you're going to use the claim. Don't worry about the don't mix up the sample with the claim. Okay. Just take care of the claim first.
Okay.
So all this has to do with the claim. Okay, now what kind of tail does this have?
This would have it's going to have a one tail, but it needs, let's see.
Yes. Yes.
Left.
Yes, very good.
Yep.
Since it's less than, it's left.
Less than is left, yes.
because it's pointing that direction.
Mm-hmm.
So it's left tail. So the alternative tells us the tail.
Mm-hmm.
So when you draw the picture, again, I'm not even dealing with the sample yet. Okay, the claim goes in the middle. So the claim is always in the middle of 60. It's left-tailed, and that's where you put the sample. The sample gave us 5888. And we need to find the probability over here. So we're finding the probability that if the null was true, we would get a sample in that region. The sample mean would be somewhere over there. So if the probability is low that we get something over there, then our null can't satisfy the null. We have to throw the null out because the probability is so low that we would get something over there. Okay, so then since we only know the sample standard deviation, okay, we don't know the population. If we knew the population, then it would be a Z problem, like number 1. But we only know the sample.
So that makes it a T problem, correct?
So it makes it, yes, a T. So we have to use the T formula. And if it was a Z problem, then you could use the Z formula also and just plug that in the formula. But it's easier just to use the calculator as it is. But here, you're going to use your sample minus the claim over your standard deviation, divide by square root of n. So standard deviation was 5.08. And we did 8 school districts. So divide by square root of 8. When you do that in your calculator, double check this too on your calculator because you may make sure that you have parentheses around your top. It really matters. And if you put parentheses around here, that also helps get your answer. This is negative 0.624. Notice it's negative because your sample is on the left of your claim. So make sure, you understand that you can get negative. If it's on the left, you're going to get a negative value.
Okay.
Just like a Z-score. So we're going to go to the T calculator. I call that like step 4. T calculator. And plug that in. So T distribution is number 12. And our T was, when we did that, negative 0.624. Degrees of freedom is going to be 7 because we had 8 weeks. So 8 minus 1 is 7. And we get a two-tailed result, 5.524. We don't want 2 tails. Ours is only 1 tail. So let's talk about that. But we get 0.55. Okay, so T point. Degrees of freedom, 7, and we get P is 0.5524, but that's for 2 tails. We want 1 tail, so we divide by 2. Now, we didn't divide by 2 the last time because we wanted 2 tails. So it's really important you decide how many tails it has. So we're going to take 0.5524 divided by 2, and it's still high, so our answer really doesn't change. So this is the probability, and our probability that our sample's over there, if the null is true, is high. It's bigger than our 0.05. Now, we always pick alpha to be 5%. Because that's just a standard level of significance. So when P is high, again, this is alpha, then the null stays. So we do not reject the null here. And that means that there is not sufficient evidence to support that the mean salary is less than $60.
Oh, okay. Okay.
Or you could say there is sufficient evidence. There is sufficient, you could do it the other way,
Mm-hmm.
to support the salary is greater than or equal to $60. So we want to keep the null here, and the null was greater than or equal to 60.
Okay.
So the most important thing, make sure, is the claim. Again, let's, in every problem, it should be easy to find. Don't mix up the
Mhm.
claim with the example, and those numbers stay the same. They're opposite. The equal sign goes with the null. The alternative tells you what tile it has. Once you decide that, then you decide Z or T. Use the formula, or for the Z problem, you can just go right to the calculator, and the calculator tells you the probability that you get that example, and that tells you if you should reject or keep the null, and then you can form a conclusion. So if you follow the steps, it won't be too difficult. And this whiteboard I can keep, which is good, and I will also post that with the video.
Okay.
I think, yeah, that was number one. Okay, this was number two. Number one, in the middle of it, I switched. So this is, number one doesn't have everything there, but it has the last three steps, and then
Mhm.
number two and number three. And then I also posted a lot of other examples. But if you have questions, please don't hesitate to get in touch with me.
Okay.
And if you want me to look at your assignments, I certainly will before
Okay. I'll email those to you. I
Okay,
need to just
cool.
go over one little thing, then I'm gonna email that to you to take a look at.
Yeah, no worries. Just take your time.
Okay.
Okay. Do you have any other questions?
No, this was very helpful. Thank you.
Okay. Well, thank you for coming on. And
Appreciate
like
it.
I said,
Appreciate
I'll
it.
post the video. All right. You have a good
Okay.
night.
You too. Thanks again.